All right, everyone. This is the second session. Um, so we're gonna continue where we left off last time. I talked about how we are going to render a bunch of tiles or a bunch of sprites on the screen. And so the idea was, and I explained that, and I said that every single tile will have something called an ID, right? So every single image here, every single one of these images will have an ID. So for example, when we do this, we're gonna, for example, say that this has an ID of 0. This is an ID of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? And so on and so forth. And this is 24, 23, 22, and this would be 25, right? So every single tile here has an ID. And the idea is we create an array, right, like so. And we say, hey, I would like to draw, let's say this has an ID of 60, right? And I want to draw a road. So I'll do 60, comma 60, comma 60, comma 60, comma, I don't know, 61. So here's 61 here, 61 here. So this is 61, right? I'm drawing the tile 61 over here, 61 here, and 60 in between. And then 61 here, and then I repeat the same thing, 60, 60, 60, and then 61, right? And so on and so forth. So I go through this array of numbers, and according to every number in the array, I draw the appropriate tile and the appropriate sprite, right? That is the entire idea. Now, before we start everything, right, before we do any of that, we need to actually go and create a tile class. So the idea here, I'm going to create a tile class. The tile class will have an ID, and it will have a reference to a texture. And this will be a pointer, right? And I'll explain pointers finally today because we need to use them. So we'll have an ID, a tile. Sorry, excuse me. A tile class will have an ID and it will have a texture pointer. Yeah, that's it. That's all a tile will have, right? Will it contain a sprite? Will a tile contain a sprite? We might also add a sprite. So a tile will also have a sprite. Yeah, so we might add all these. So a tile will have an ID, a texture pointer, and a sprite. Okay. All right. I think that is it. That's the idea here. So let's implement that. Before I implement any of that, I want to talk about pointers. Pointers, and I explain what pointers are, right? Because it's kind of important. All right. We talked about references before, right? We covered references, and we said a reference will be a memory address. So if I have a window object, so I have a render window. So render window, right? And this has an object of window. So my class is called render window. The object is called window. And I want to pass this to a function. Let's say this function is called draw. And this function we will pass the window as a reference, which means this is an AND. I don't know how to draw an AND. Like this. This is an AND. I don't freaking know how you guys draw an AND. There you go, an AND. ANDs are stupid, right? This is an AND, and it's a reference of window, right? So now, instead of passing a copy, instead of passing by value, I am passing by reference. I'm not copying this window in here. I am passing the actual window, and the window has a memory address, right? Now, whenever I pass by reference, right, I'm passing by a reference, which is the AND, right? This reference over here, I'm passing by it. I'm passing the memory address. However, I cannot change the memory address later on, right? If I decide to need to change it, I'll not be able to change it later on. And the question is, why would you want to change it later on? So this is where pointers come in, right? So I'll explain why you might want to change the reference in a second, or the memory address in a second. But imagine this. Imagine in memory, I have a texture here called T1. I have a texture over here called T2. Right? This is like a 10 MB texture, 10 MB. This is another 10 MB or 20 MB texture. Okay. If I create a variable of type texture, okay, and I call it T. Now T can point to T1, or it can point to T2, right? What if I want to have another texture called R? R can either point to T1 or it can point to T2. So T can point to T1, for example, R would point to T2, okay? And if I have another variable called texture, right, called C, C might also point to T2, right? So you can see that these variables, they point to the same texture. Rather than this variable pointing to a new box, rather than creating a new box here and call it T3, which is the same thing as this texture, so this is another 20 MB, right? These textures are identical, they're the same. Rather than C pointing to T3 over here, right? So now in memory, we're consuming 10 MB plus 20 plus 20, so 50 MB. Rather than consuming 50 MB, what we do is we make C points to a texture that already exists, which is T2, right? This is the entire point of a pointer. A pointer holds a memory address, just like how a reference holds a memory address. The difference is, a pointer, we can change the memory address later on. We can change what C points to. So I can say that today, or at this point in time, C is pointing to this texture. But later on, maybe I want that C points to T1. I decided now that C points to T1, right? Rather than T2. So with a pointer holds a memory address. So just like how you have an integer, what does an integer hold? An integer holds a number. It holds 1 or -1 or 5 or 10. All these numbers are held by an integer. So an integer holds a number. A string holds a character. So for example, not a character, a bunch of characters, like hello. A pointer holds a memory address, which is 0x00153, for example. This is a memory address. A int holds a number. A string holds a set of characters. A pointer holds a memory address. And so if I make the texture, if I say that texture C, if I say texture C is a pointer, and the mark for a pointer is an asterisk, an asterisk. Damn it, stupid word. I can never pronounce that word ever. I can't even spell it. Asterisks. There you go. Pronunciation. Asterisk. Whatever, such a stupid. I'm gonna call it a star. Jesus Christ. Asterisk. Whatever. Right? So a pointer has the star symbol next to it, right? So whenever you see a pointer, whenever you see the star, that means this is a pointer. And a pointer holds a memory address. That's what a pointer holds, right? A string holds collection character. An integer holds a number, for example 15. A pointer holds a memory address. And a pointer, I can change what this pointer points to. So it can point to either this texture or it can point to this texture. While a reference has the and symbol, right? And let's call it D. This will also hold a memory address, but the difference is I will never be able to change what D points to. If I see that D points to T2, that's it. D points to T2. I cannot change it later on. I cannot decide that later on D points to something else. While a pointer can change. Pointer can go here, pointer can go there. Right? Okay. So references are usually used when you pass something by a function. So you see here, whenever we're creating here, so if I go to the draw window, right, I am using the reference, right, the and symbol here, to pass by reference, meaning window cannot point to something else. So whoever calls the draw function, so I'm calling the draw function here for the map. Where's my here, right? I'm calling map.draw and I'm passing the window. Window is being passed by a reference, right? And I cannot change what this window reference to. If I pass it, that's it, I pass it. While a pointer, I can change what it points to. I can later change what it points to in the future, right? And with a pointer, at the same time, a pointer can point to memory addresses. You can delete a pointer using the delete keyword. So with the delete keyword, I can delete the memory in that pointer, and I can create new memory with the new keyword. I'll talk about these later on, right? Not now. I don't want to add too much confusion for you. All I want you to know, all I want you to understand, a pointer points to a memory address. That's what a pointer has. A pointer is a box that has a memory address. Just like a string is a box that contains a set of characters, just like an integer is a box that contains the value 15 or a bunch of numbers. A pointer is a box that has a memory address. And this memory address is a memory address of something else in memory. It could be a texture. It could be this texture. It could be this texture. It could be anything. It could be anything you want, right? Okay, so in here, for example, I created a pointer of type texture. I can create a pointer of type integer. I can create a pointer of type string. I can create a pointer of type map. I can create a pointer of type bullet. Right? All of these are pointers. Star, 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 right? All these are pointers and they all point to different things, right? So this is, let's call it N, this is B, this is M, and this is B. Let's call this A, right? So the variable here is A, the variable is N, the variable is M, the variable is B. The data type is a bullet. It's a pointer bullet, and it points to a memory address, right? So all of these, they hold memory addresses. They don't hold the object themselves, they hold memory address. Think of it this way. I would like you to think of it this way. Think of it this way. What's a good analogy for this? A pointer holds a memory address, right? Okay, think of it this way. Imagine there's a guy, okay, and you ask the guy, hey, listen, so this is you over here, this is you, and you go and talk to the guy and ask him, right? This is a speech bubble, apparently. And you ask him, where is my house? Or where's your house? And so what he does, he will hold his finger and he will point to the house. I'll be like, hey, this is the house. This is where the house is. This guy is a pointer. He pointed to the house, right? He doesn't own the house. He doesn't hold the house. He cannot destroy the house, right? All he does, his entire job, his entire existence, he was born for one thing and one thing only. His entire life up to this point, pun not intended, up to this point in time is to point to this house. He went through hardship. He studied computer science. His entire purpose. You know you know that ooh, I need to show you this. You know that episode in Rick and Morty where this guy asks, "What's my purpose?" Right? His entire purpose in life is to pass butter. This guy's purpose in life is to point to this specific house. And that's what a pointer, ladies and gentlemen. This guy's as a pointer, and no one likes a fucking pointer. Alright, cool. So, that's what a pointer, literally, right? This guy is just pointing to a house. He doesn't own the house. He just points to the memory address, or he points to the address of the house, right? And so that's all these are pointers, and they all point to different things in memory, right? The memory is just it's a neighborhood. It's your lovely, friendly neighborhood Spider-Man, right? Just a neighborhood, right? There's a house over here. There's a house over here. There are some bullets here. There are a bunch of enemies, a bunch of sprites, maybe a player over here. And so memory address, this here is a pointer, and all he does, he points to a different memory address. That's what a pointer is. And sometimes they can point if I tell him, hey, you, stop pointing to this thing. Point somewhere else. And so he points to a different location in memory. So now the question is, why would I create something that points to something else? Why can I not just go to that thing? Well, sometimes you need to pass variables around, right? Sometimes you need to, like, sometimes I need this variable in a different class, or I need this variable in a different array, or I need this variable somewhere, right? And so to be able to get to it, I need something to point to it, right? So I create something that points over here, right? And so I can use this something, right? I can use this object, this pointer here, I can use it so it can point to somewhere, and I can use this. My end goal is to go here. And so pointers, the entire point of pointers is they point to other things. And they're very useful, and we'll see why they're super useful. In our example here, right, in the tile class here. So for example, when I create my tile class, right, I'm going to create a texture pointer, right? So my texture is somewhere in memory here, right? This is my texture, right? And now my texture exists in the map. Let's say my texture exists in the map. So I load my texture and it exists in the map. But every single tile, every single tiny little lovely, beautiful, absolutely gorgeous, fantastic looking tile needs to point to this texture. They need a reference to it. They need to be like, hey, I know where this texture is, right? So for example, if I am drawing this tile, if I am drawing this sprite, right, and I draw it, and I want to figure out what texture it's using, I can just access this variable and I see where it's pointing to. Where's this tile? Which texture is it pointing to? Is it pointing to this texture over here, or is it this texture, right? And this is very good because the alternative is to copy the texture. So this is a 10 MB texture. So I basically copy 10 MB over here, copy 10 MB, copy 10 MB, copy 10 MB, 10 MB, 10 MB. So now I have 1, 2, 3, 4, 5, 6, 7. I have 70 MB because I have 7 tiles. That's really wasteful. So instead what I can do is make a pointer, and a pointer is really small. A pointer is 8 bytes on a 64-bit machine. And we haven't talked about the sizes of variables. We'll talk about those later on. But it's just an 8-byte. It's an 8-byte variable that points to a 10 MB texture. So every one of these tiles will point to these textures. So if I ever want to draw a tile, or if I ever want to know what the style, which texture is it using, I can just check out the pointer and it tells me what texture it's pointing to. And so that's why I kind of need the pointer over here, right? And I could have passed by reference. I could have done that. I could have made this a reference, not a pointer, right? But sometimes those styles will point to a different texture, right? So maybe I'm in level 1. And level 1 over here, I am in the prison level, right? And so they point to the prison texture. Maybe now I'm in level 2. So now that same tile needs to point to a different part of memory. So it points to the second level. Right? And the second level is a beautiful green forest. If I made this a reference, then it can only point, right? It can only point to the first level. You'll not be able to point to the second level. But a pointer, on the other hand, can point to a different location in memory, which is awesome, which is super cool. That's why we need a pointer, right? And they're very, very useful, right? Now, the other example and the other problem that we have right now currently in our game, and I said we'll fix this at some point, you will see that inside the skeleton, I am loading a font. And inside the player, is it the player? No. Oh, so inside the skeleton, I'm loading a font, and inside my frame rate, I'm loading the same font. So the font is being loaded twice. If I had a pointer, right, then that pointer, both these pointers for both fonts, so this is the font for skeleton, right? This is my skeleton font, and then the font for my player, or sorry, frame render frame, or frame rate, right? Both of these, they are basically using the same font, but in memory, what's happening right now is that there's font over here. I'm loading this font, and I'm loading another font. So if this font is 1 MB, that means in memory I'm using 2 MB. This is 1 MB and this is 1 MB. This is really bad. And so maybe if I want another class to use a font, I'll have to load another font, which is 3 MB now, which is bad. So instead, what I could do is I could create a class, a resource manager class. For example, a loader class, an asset loader class. Its job is to figure out whether this font has been loaded previously. So if I loaded this font previously, what I should do is, rather than loading, if the font was already loaded, rather than loading a new font, I will just return a pointer to this font. Right? So now skeleton points to this font over here, rather than loading a new one. And so so at the very start, where there's no fonts loaded, there are literally no fonts loaded. So I say, hey, skeleton, please load a font. So it goes check. Does this font exist? No, it doesn't exist. I should load it in memory, and I should give you a pointer to it. Now the frame rate goes and checks, and he's like, okay, listen, I need this font. And so in the resource manager class, it checks. He's like, hey, do I have this font? Oh, cool, I have this font. Rather than loading the font again, I'm going to give you a pointer to that font. I'm going to give you a location in memory that font exists. The problem, if this font is deleted later on, these pointers now points to a place in memory that is not valid anymore. And that's one of the issues of pointers, is that if this resource was deleted, now these pointers, they just point to somewhere in memory that has nothing. And if I try to use that pointer, the application will crash. That's one of the downsides of a pointer. But they're extremely useful, because rather than loading the font 600, 700, 800 times, every class that needs a font and the same font, like the Arial font, the same Arial font, we can just point to that font rather than loading a new one. And so pointers are extremely powerful, and they're extremely useful, and they're extremely fucking dangerous, right? So there you go. So that's the difference between pointers and references. References, you only assign a reference at the very start, and only once, you only do it once, where a pointer points to, a memory location, and you can change that memory location. You can change where this points to later on. And you can create multiple pointers. You can make an int pointer, string pointer, a texture pointer, a sprite pointer, a bullet pointer, a map pointer. You can do whatever the fuck you want pointer. That all these work, right? So pointers are really, really powerful. All right, going back. So those are pointers. Pointers are done. We've explained pointers. Now let me show you how to use pointers. Right? I'll go with a very simple example, right? So let's go here. So for example, let's say I have the variable int phone number, and the phone number is 055778899. Right? This is a phone number. Right? If you don't like this phone number, well, you know what? Tough luck, buddy. Invalid octa-digit? The fuck do you mean? How many digits did I add? Okay. Oh, because I started with 0. It thinks that it's an octa-digit. This is hexadecimal. Oh, this is cool. Okay. See, look. Okay, if you do 0x, it knows that this is hexadecimal, and so decimal, the number is actually 5601160. But doesn't matter, right? Okay, so this is a phone number, right? 557788. This is a phone number. Okay, so what I can do now is create a pointer that points to this phone number, and I can call it the pointer with that tone. Now to create a pointer, you have to add a star in here. So this is a star. We're saying that this points to somewhere. Right now, it points to nowhere. And I can say null pointer. Null pointer means this is a null pointer. The null keyword means nothing. It means 0. Null means 0. And if you type null, and if you hover over it, and you can look at it, it says 0. Null is 0. So this is pointing to the memory address 0x0000000000000, and so on and so forth, right? It's pointing to 0. It's pointing nowhere, right? So that's what null PTR. PTR means pointer, null means 0. So this is pointing to nowhere. I want it to point to this phone number. How can I do that? Well, I created a pointer of type integer. Right? If I want this to point to an integer, I need to make an integer pointer. If I want this to point to a string, I need to make a string pointer.